Good morning, students. This is SHAFI from Don Bosco PU College, Chitradurga. Welcome back to the maths class. In our previous class, we have solved the questions related to range and domain of the function. Here we have the next question that find the domain and range of the function f of x equals to square root of x minus 1. We have to find the domain and range. How to find the domain and range? You just see the previous class, you came to know that the procedure of finding the domain and range. First write down the given function, given that f of x equals to square root of x minus 1. You take the values of x, you just take the values of x, you just think that in place of x, if you take 0, then what will happen? In place of x, if you take 0, then what will happen? Square root of 0 minus 1, square root of minus 1 will come. I already told you that this function is a real function. Real function is nothing but domain and range should be a subset of a real numbers, right? If we take 0, then we will get to square root of minus 1. That means it will be a complex number, so that we should not take the value 0. Let us take the values from plus 1 equals to square root of 1 minus 1. You didn't understand or what? Once again, if we take f of 0, then what will happen? Square root of 0 minus 1 will come. Then square root of minus 1. If it is a square root of minus 1, it will be a complex number. Therefore, complex numbers are not defined in this real function. So that we should not take the value 0 from 1 to we are taking the values f of 1. What about f of 2? Square root of 1 minus 1 is 0. F of 2, square root of 2 minus 1. Then it will be root 2. What about f of 3? Square root of 3 minus 1 equals to root. It will be root 1 equals to square root of 1 is 1, root 2, and so on, isn't it? Now, what about if we take the values, negative values? F of minus 1 equals to square root of minus 1 minus 1. Then what will happen? Equals to square root of minus 2. Square root of minus 2, it will be a complex number. Therefore, complex numbers are not defined in a real function. So that we should not take f of minus 1, f of minus 2, f of minus 3, and so on. Now, you just observe these values, then you just write down the domain and range for this function. Domain is what and range is what? First, domain. Domain, you just observe. Here we have taken the values from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and so on. I mean all positive numbers, all positive real numbers except 0. All positive real numbers except 0. 0 we are not taking, isn't it? If we take 0, then we will get a complex number. Domain will be all the real numbers, all the positive real numbers except 0, or symbolically you can represent it as a 1 is included up to infinity. Infinity is excluded, like this. What about range? I already told you that outputting values are the range for the given function. 0, 1, root 2, 0, 1, root 2 is nothing but 1.12, root 3. Like that we are getting the outputting values 0, 1, root 2, next again is root 3, next again root 4. Like that we are getting the values. Then what about the range will be? What about the range will be? 0 is included, 0 is included up to, we are getting the positive numbers up to plus infinity, 0 to plus infinity. Or you can write all the positive real numbers including 0, all the positive real numbers including 0, or else all the positive real numbers including 0. It is the symbolical representations of the domain and range. Or else you can write in a sentence form like this: all the positive real numbers except 0, all the positive real numbers including 0. Hence it is the domain and range for the function f of x equals to square root of x minus 1. Now let us move on to the next question. It is the next question. Note down: which of the relations or functions give reason if it is a function? Determine its domain and range. These kinds of problems I already explained in the starting of the functions. If you want to know about these kind of problems, you just see the previous class. That class includes the definition of the functions along with their examples. Now here we have the first sub question: 2, 1, 5, 1, 8, 1, 11, 1, 14, 1, 17, 1. It is a relation. Is this relation is a function? Is this relation is a function? In our previous class, I already told you that, or you can see the functions definition along with their examples. Then you came to understand what I am explaining in this problem. Function is nothing but every element in the domain has one and only one image in the codomain. It is called a function. You just see, if the second element not a second element, first element. If first element of the ordered pair repeats, then it is not a function. Once again, the first element of the ordered pair repeats, then it is not a function. Otherwise, it is a function. Here we have 2, 5, 8, 11, 14, 17. You just observe the first element of the ordered pair: 2, 5, 8, 11, 14 and 17. Here first element is not repeated, therefore hence it is a function. If you want to represent this relation in an arrow diagram, you can represent this relation in an arrow diagram. Before that, you just read the definition of a function along with their examples, what I explained in our previous class. 2, 5, 8, 11, 14, 17. First element of the ordered pairs, these are 2, 5, 8, 11, 14 and 17. What about second element? 1, 1, 1, 1, 1, only 1. 2, 1, 2, 1, 5, 1, 5, 1, 8, 1, 8, 1, 11, 1, 11 1, 14 1, 14 1, 17 1, 17 1. According to the definition of a function, every element in the domain has one and only one image in the codomain. Therefore, it is a function. 2 has only one image 1, 5 has only one image 5, 5 has only one image 1, 8 has only one image 1, 11 has only one image 1, 14 has only one image 1, 17 has only one image 1. Therefore, it is a function. What about the domain and the range? Range is nothing but the set of all images in the codomain is called range. Here the set of all images image is only 1. Therefore, range is 1. What about domain? 2, 5, 8, 11, 14 and 17 is a domain. Or the first elements, the set of all the first elements of the ordered pair is called domain. The set of all the second elements of the ordered pair is called range. Before that, you have to write the reason why it is a function. Every element has one and only one image. Every element has one and only one image. Let us consider it is a set A and it is a set B. Every element has one and only one image in the set B. Therefore, it is a function. What about the domain and range? Domain and range. Domain will be the set of all first elements of the ordered pair. 2, 5, 8, 11, 14 and 17. 8, 11, 14, 17. Range is what? Only 1. Therefore, it is the domain and range for the relation 2, 1, 5, 1, 8, 1, 11, 1, 14, 1, 17, 1. Next sub-question B. Write down the relation 2, 1, 4, 2, 6, 3, 8, 4, 10, 5, 12, 6, 14, 7. Is this relation is a function? It is the question homework for you. By seeing the relation itself, we can answer that whether it has a function or not. Function, how to verify this relation is a function? The first element of the ordered pair should not repeats. If it repeats, therefore it is not a function. 2, 4, 6, 8, 10, 12, 14. First element is not repeated, therefore it is a function. What about the domain and range? Domain will be 2, 4, 6, 8, 10, 12, 14. What about the range? 1, 2, 3, 4, 5, 6, 7. It is a range. Now, third sub question. Write down the relation 1, 3, 1, 5, 2, 5. Is this a function? According to the definition of a function, the first element of the ordered pair should not repeats. If you want to represent this in a arrow diagram, you can represent 1, 1, 2, that is 1, 2 only. 3, 5, 5, that is 3, 5. 1, 3, 1 is related to 3. 1, 5, 1 is related to 5. 2, 5, 2 is related to 5. 1, 3, 1, 5, 2, 5. Is this a relation? according to the definition of a, is this a function? According to the definition of a function, every element in the set A has one and only one image in the set B. Therefore, here we have, for the element 1, we have two images, 3 and 5. Therefore, it is not a function. For the element 1, we have two images, 3 and 5. Therefore, it is not a function. Write down the reason why it is not a function. For the elements, for the element 1 has two images in the set B. Therefore, for the element 1, we have two images in the set B. Therefore, it is not a function. Understood? So these are the problems related to domain and range. You just write down these questions, these answers in your notebook. Kindly do not make any kind of mistakes. Now let us move on to the next question. Write down the next question. Let f equals to 1, 1, 2, 3, 0, minus 1, minus 1, minus 3 be a linear function from z into z. Find f of x. Linear function, we have to find the general form of a linear function for this function. We have to find a linear function for this function. Let us define a linear function. Linear function we will define like this: f of x equals to ax plus b. Linear equation like that. Linear equation, we know that linear equation is what? Ax plus b. Similarly, linear function will be in the form ax plus b. F of x equals to ax plus b. Now, by using this given function, we have to find the values a and b. By using the given function, we have to find the values a and b. Later, we have to substitute that values in this equation. Finally, we will get a required linear equation for the given question. Once again, linear function. F of x equals to ax plus b is a linear function. Let f of x equals to ax plus b is a linear function. By using the given function f equals to 1, 1, 2, 3, 0, minus 1, minus 1, minus 3, by using this function, we have to find the values a and b. After that, we have to substitute that values a and b in this linear function, that is the required linear function for this question. Are you understand? Now, given that, write down the given function. F of 1 equals to 1, 1, 2, 3, 0, minus 1, minus 1, minus 3. Before that, call this as equation number 1. It is a given function. Now, by the definition of a function, it is not a f of 1, it is only f. F equals to 1, 1, 2, 3, 0, minus 1, minus 1, minus 3. By the definition of a function, f of 1 equals to 1. F of 1 equals to 1. Next, f of 2 equals to 3. F of 2 equals to 3. Next, f of 0 equals to minus 1. F of 0 equals to minus 1. Next, f of minus 1 equals to minus 3. F of minus 1 equals to minus 3. Once again, f of 1 equals to 1. F of 2 equals to 3. F of 0 equals to minus 1. F of minus 1 equals to minus 3. Right? Now, you just use this linear function here. Here we have 4. Here we have 4 values we have. You can choose any two. Either you can choose f of 1 equals to 1, f of 2 equals to plus 3, f of 0 equals to minus 1, f of minus 1 equals to minus 3. I will choose these two. I will choose these two for to find the values a and b. I will choose f of 1 equals to plus 1, f of 0 equals to minus 1. I will choose these two because it is very easy to find the values a and b. Or you can choose any two among these four. F of 1 equals to 1. It is in the form f of x, ax plus b. Ax plus b equals to 1. Ax plus b equals to 1. In place of x we have 1. That is a plus b equals to 1. A plus b equals to 1. Now I am not choosing f of 2 equals to plus 3. I am choosing f of 0 equals to minus 1. Now f of 0 equals to minus 1. F of x is what? Ax plus b. Ax plus b equals to minus 1. Right? Ax plus b equals to minus 1. Now in place of x we have 0. You just substitute in place of x with 0. A into 0 is 0. 0 plus b equals to minus 1. B equals to minus 1. Therefore we found the value b. B is what? Minus 1. You just substitute this b equals to minus 1 here. You just substitute this b equals to minus 1 here. We will get the value a. Substitute b equals to minus 1 in the above equation. In the above equation. Then a, b is what? Minus 1. Minus 1 equals to plus 1. Therefore a equals to, if we send minus 1 to the right, it will be 1 plus 1. A equals to plus 2. A equals to plus 2. Right? Therefore a equals to plus 2, b equals to minus 3. Now you just substitute this a and b in the equation number 1. Finally we will get a required linear equation. Substituting a equals to plus 2, b equals to minus 1 in the equation 1. In the equation 1 what we have? F of x equals to x plus b. F of x equals to ax. A is what? F of x equals to ax plus b. In place of a, that is 2x plus b. B is what? Minus 1. Therefore f of x equals to 2x minus 1. Hence it is a required linear function. Yes. Now we can write down this question in your notebook. You just take a screenshot or pause the video. Okay, dear students, hence it is a class for today. For the next class, kindly make sure you will have the graph sheets. In our next class, we will continue with the other type of problems. Make sure you will have graph sheets. Thank you.